You know that sometimes you wish it would rain and it doesn't. And you know that if we want to cause it to rain, we can seed the clouds, usually with like little tiny pellets of dry ice, carbon dioxide, dry ice, frozen carbon dioxide. We can seed clouds sometimes and increase the rainfall because it so happens that clouds are composed of water droplets, little balls of water, little tiny microscopic balls of water. I believe you can almost see them if you're trying to drive through the fog with your headlights on. You can see these little droplets of water. You're looking at clouds. Clouds are actually composed of billions and gazillions of little tiny droplets floating in the air. Well, these droplets are independent of one another and remain independent of one another, do not condense further beyond that stage because of a phenomenon called surface tension, which is easy to understand. You've seen a spider run across the surface of the water of a pond or a creek. You've seen a little spider who's able to walk on water, and that's because of surface tension. And you know that if you were to extend your finger into the water and watch very carefully, the water would appear to jump up around your fingertip. You know that if you put a glass rod in water, it jumps up and climbs. It climbs that rod a slight amount. You can see it move. In other substances, if you extended a glass rod or your finger into them, instead of leaping up toward the object, they would concave downward. You could actually push downward on it. Surface tension. The reason water has surface tension is each water atom molecule, each water molecule is attracted to the other slightly because one end of the molecule is positive and the other is negative. So it's like a whole lot of little bar magnets. Each end has a opposite charge, and so of course the positive end of a bar magnet would be attracted to the negative end of another bar magnet, and this is the way water condenses. This is the way water condenses. This is the way water condenses. So water, when the temperature drops, water gaseous water condenses automatically into droplets when the temperature drops. When the temperature increases, these droplets evaporate. We're talking about evaporation of water, which you can understand. If you ever hung your clothes on the clothesline, you know that water evaporates. You know that if the air is dry and the air is moving, and the air is warm, your clothes will dry sooner. If the air is damp and still and cool, your clothes could remain damp for a long time. Okay, so this is simple stuff. This is simple stuff. A child can understand this. But apparently, an error has been injected into this debate involving the astrophysicist named Henrik Svensmark and the astronomer named Nir Shaviv. An error has been inadvertently injected into the debate, so now they're working off of a false premise that you can easily see, but they can't see because they're brain locked. They're brain locked. They erroneously believe that clouds require cloud condensation nuclei to form. No, they don't. Water automatically condenses when the temperature is right. It has to do with atmospheric pressure, temperature, and movement of air. If the air is still and cool, uh, gaseous water will condense into little droplets. But then surface tension takes over, and each droplet repels the other. At that point, a little bit of dust, some other material floating in the sky, triggers the formation of a raindrop.